Lesson 22: Extracting State Logic into a Reducer. 1. Introduction. When a component grows and handles many different state updates across several event handlers, the logic can start to feel scattered and difficult to maintain. In these cases, it helps to move all state update logic into a single function outside of the component. This function is called a reducer. Reducers help centralize how state changes happen. Instead of updating state directly inside event handlers, the component simply says what happened, and the reducer decides how the state should change. 2. Consolidate state logic with a reducer. As a component gets more complex, it becomes harder to see clearly all the different ways its state may change. For example, a component that manages a list of tasks might have separate event handlers for adding, removing, or editing tasks. Each of those handlers updates state directly inside the component. By moving all these update rules into a reducer, we keep the component more readable and maintainable. The reducer becomes the single source of truth for how changes occur. To move from direct state updates to a reducer, there are 3 main steps. 3. Step 1. Move from setting state to dispatching actions. Right now, event handlers contain state update logic. For example, a handler that adds a task updates the list by inserting a new element. A handler that edits a task updates the matching element. A handler that deletes a task removes the matching element. With reducers, you don't update the state directly. Instead, your event handlers describe what happened by sending an action. An action is a plain object that explains the event, such as, a task was added, a task was changed, or a task was deleted. Each action has a type describing what happened and includes only the minimal extra information required. The reducer will later decide how that action affects the state. This approach makes event handlers simpler and more focused on user intent rather than logic. 4. Step 2. Write a reducer function. A reducer receives 2 things. First, the current state. Second, the action describing what just happened. Its job is to compute and return the next state. All the logic previously scattered across event handlers is now collected here. It checks the action type and uses the action data to create an updated version of the state. If the reducer receives an unknown action type, it throws an error so you can identify mistakes early. Although reducers can be written using if-else conditions, it's common to use a switch style structure because it reads more cleanly when handling multiple types of actions. Why are they called reducers? The name comes from the concept of reducing values over time, like accumulating multiple actions to derive the latest version of the state. 5. Step 3. Use the reducer from your component. Now that you have a reducer function, the final step is connecting it to your React component. Instead of using state directly with useState, you swap to useReducer. This hook takes the reducer and an initial state, and returns the current state along with a dispatch function. The dispatch function is what event handlers will call to send actions to the reducer. The reducer then calculates the new state, and React updates the component accordingly. You can even store your reducer in a separate file if you want to keep your component code even cleaner. This separation improves readability because event handlers only express what happened, while the reducer exclusively manages how state should change in response. 6. Comparing useState and useReducer. Both approaches are valid and equivalent. Here's how they compare. Code size. useState can be quicker for simple cases. useReducer may require more setup but keeps complex logic organized. Readability. useState works best when logic is small. useReducer shines when logic grows large. Debugging. useReducer makes it easier to see which action caused a state change, improving debugging. Testing. Reducers are pure functions and can be tested in isolation. Personal preference. Some developers prefer reducers while others prefer direct state. You can mix both techniques in the same component. Reducers are helpful when a component frequently experiences state-related bugs or feels difficult to maintain. 7. Writing reducers well. 2 guidelines are essential. Reducers must be pure. They should only compute the next state based on the inputs and never perform actions that cause side effects such as fetching data or modifying things outside their scope. Each action should represent a single meaningful user event. Even if one event changes multiple pieces of data, it should still be represented by one clear action. If you log all the actions in your reducer, the log should be enough to reconstruct exactly what the user did and in what order. 8. Writing concise reducers with IMA. React reducers must not mutate state directly. However, libraries like IMA allow you to write reducer logic in a simpler style that looks like mutation, while IMA handles creating an updated copy behind the scenes. This can make reducer code shorter and easier to write. 9. Recap. To convert from a stateful component using useState to one using a reducer. Event handlers dispatch actions instead of updating state directly. A reducer function determines how each action updates the state. Replace useState with useReducer inside the component. Reducers may require a little more code up front, but they help a lot with structure, debugging, and testing. They must always remain pure and handle one user interaction per action. When desired, IMA can make reducer code more concise.